Merci. Bonjour, everyone. It's a pleasure to see all of you. I can feel the energy in this virtual room. I turn on my camera briefly at the beginning just to show you that this is not AI generated in any way. It's still a human being in the back end doing this presentation, and I look forward to presenting the remaining content in this presentation. We'll open up questions at the end. I expect about 25 to 30 minutes of presentation with a small live demo that we're going to do together. So thank you very much for attending. I'll turn my camera off and we'll get started. Awesome. So who am I? I've worked in the simulation and visualization space for more than 25 years now. I've had the opportunity to lead different teams in different companies. I've been with WSP for more than 11 years now. I've worked at Synthetic, a smaller company that did training, real-time training for troops and military situations. I've also worked at CAE, our civil aviation training here based in Montreal. So quite a lot of different companies where I had the opportunity to develop and hone in my skills on real-time solutions. So I'm based in Montreal in the head office. It's a pleasure to be presenting what we've been working on for the past years. So what is our statement? We've been creating visuals for more than 25 years. The expertise we acquired allows us to accompany our customers, which is really important to us. It becomes a journey together and not just a client. It's really how do we offer our best solutions to fit their specific needs. And as you all know, new technology continues to emerge throughout the evolution of digital solutions, and we make sure that all of these solutions are always presented to our customers in their best fashion so that they can maximize its use and profit from them. So stakeholder engagements. What is a stakeholder engagement? As I know that not necessarily all of you know exactly what it is, we'll just go through the definition. Well, it's actually it's the engagement process where an organization decides to involve others to help in its decision making. So it's a way of communicating the ideas and the vision that the project will have and getting feedback and responses so that the project becomes an intertwined set of feedbacks and sessions that will eventually yield a better project from all of the inputs coming from different stakeholders that have different opinions and also different realities based on their vision of the project. So we, as WSP, present the tools, present the solution, but we do not offer a personal, is it good or bad presentation. We just make sure that the content is as accurate as it can be. Why did we start with real-time visualization in wind farm projects? Well, because they are becoming more and more visible in our landscapes. They are often positioned at the top of mountains, so quite evident. They cover large areas, sometimes more than 40 by 40 kilometers. So to my US friends who may be on the call or other international, 25 miles by 25 miles, which represents roughly 1,600 square kilometers of area, which is a lot. The image that you see is actually taken from our real-time visualization for one of our projects where we're representing. So some of the content that is 3D, I'll always highlight it so that you can easily identify it. Turbines, wind turbines, just again, for people who are less familiar with the whole concept, it's made up of blades, a turbine head where the energy is produced, and the mast where it actually sits on the ground. Now, why are these three components important? Well, it all relates to their height. They can be quite tall, up to 120 meters high, including the blade length. The rotation speeds can reach up to 160 kilometers at the tips. It doesn't always feel that way when we're looking at them, but they do turn quite fast. And obviously, for safety reasons, there are cutoffs to these, which can, in high wind or various conditions, stop the rotation of the blades. So all of these have a sensory impact on us who live in near, close to them, or see them going to work or in other types of activities. So the spinning blades can actually create stroboscopic effects from the sun that passes through at the perfect angle, and this can greatly impact certain people. The large size in itself will cast a strong shadow on the ground. So obviously, if you have a residence nearby, it could possibly impact you. These things are so tall that they need obstruction lights at the top, which are usually red and blinking, sometimes also on the mast itself due to different local legislation or laws. And this can obviously be visible at night. And finally, they generate noise at different frequencies, which can be heard or also felt in some occasions. So traditionally, a stakeholder engagement approach was going to a town hall, present some boards, present some pictures that were taken on site, which we call photo simulations. And these do a great job because we can see the actual site where the image was taken, but what's happening left and right of that image? We can't capture the full thing. So obviously, when we're talking about 40 by 40 kilometer areas, it's important to be able to move to any of those locations and see a bit more than just a couple of limiting viewpoints. So as you'll see in the images, this is an actual on-site picture taken for a project, and this is the 3D render added to it. Now, this is great, but we only see 2 of the other 82 turbines comprising and making up the project. So it's time for a change. To complete this solution, it doesn't replace it. It adds to the possibilities that are now that our clients and that stakeholders ask for. So how did we get to develop these things? It's by listening in public assemblies and hearing what our customers were telling us and saying, well, we have people inside the rooms asking questions such as, what will it sound like? What is it going to look like at night? Will I see it from my house? When I'm doing my outdoor run in the mountains, will I see it in the trail that I use? So all of these different questions came up, and we said, we believe we have a solution for you. And by this is by creating a real-time environment. So what are the typical data inputs to create these? Well, we use GIS data that comes from different sources, either project-based or government created. We have internal studies such as acoustics. We have topography, the project layout, which is quite important, the exact location of the turbines themselves, and the size of the turbines that are making up the project. In our software workflow, I won't get into details, no worries, this is not a technical presentation to that extent, but it's just to show how different sources are ingested within our approach. So we use existing software licenses that are mainstream, such as ArcGIS, Autodesk software suites. All of those data that are created from our customers and government agencies, we're able to ingest. We're able to create our own content when necessary to support the customer's vision and their needs. And then we go through the different inputs to go into a real-time visualization software. Now, some of you already picked up on the left-hand side, some that are keen. We'll see that we mentioned Unreal in some of the slides, but we're not limited to. There are different softwares out there that do best, that have their strengths, but this presentation, all of the content that you'll see has been made in Unreal. So I'm going to try something cool with you. We're going to do a live project demo. So be aware that sometimes we do get surprises when we do these types of presentations. So let me just flip this out. This is all web hosted. So we're actually connecting to the cloud. Takes a few seconds for the virtual machines to ramp up. And because we're on Teams, you will notice that you get a bit of a lag in your visuals. So this is not typical when we're live with the model. It's through the sharing of the content in Teams, GoToWebinar, and other streaming presentation softwares like we are right now. So this interface is publicly available for some of our customers. Sometimes our customers want them to be hosted on a portal. It makes it really easy to navigate. Sometimes for stakeholder engagement, you want to have a certain control during the presentation and during the audience. Not that we don't want people wandering anywhere. It's just that if you have 300 people inside a room, we can't just give full control during those presentations. So that's why we have these web-hosted sessions that can be accessed after the presentations, depending on how the customer decides to set it up. Now, this is a region in Quebec, so we have different areas, and all of these little tags that you see are POIs, or points of interest, to which we can quickly navigate to. As you can see, the camera pans to the ground, and we are using forestry data coming from the Ministry of Forests that has average tree heights, tree species in that area, and other details that allows us to recreate the density and the look for a closer representation. We're not aiming to have photorealistic one-to-one. We're creating a tool that allows people to have an idea of what the project will be once it is built. And that's why the photo simulations showed earlier complete that solution. But what's fun in this one is we're able to turn on and off the vegetation at any time, and suddenly we see our little wind farms starting to appear. We can also heighten the wind farm by putting them all black, and this gives us the possibility to see them. You're also noticing that they are spinning, maybe due to your frame rate through the presentation. It doesn't give that, it doesn't come off the same way, but they are spinning at an average speed. And we created a small wind direction map that could be coupled with actual wind conditions, but for this specific ones, we did not. And the reason why we created this little widget is to assure that people can see the worst wind direction, which has the wind turbine 100% visible or slightly turned, depending on that day's wind condition. So instead of just showing optimal side views, we're giving the whole thing a possibility. Now, sorry if you saw my email pop up. I don't believe that was planned. We also have the possibility to move inside, and that's where the real time comes into. And you'll see it probably stutter a bit on your end, but I can move this up and down at any point and change location. So if somebody wants to actually go and see what it's going to look like from their bedroom, we can, or from their backyard or from their kitchen area, it's all possible. So if we continue to move on, we were asked to do a winter scene because here in Canada and in more northern countries, Leaves fall, so it has a direct impact on the perception of the projects as we can see through the trees without the leaves and such. So this environment is all real time. Sorry for the little stutters. I'm just gonna reset it. And we created a 6 kilometer ski trail that is an actual existing ski trail in the area, which will take an hour and a half. So I hope you brought your lunch. Just kidding. We can at any time stop and move our little character anywhere along the ski route, and also turn our heads to explore each direction. And the reason behind this, as I showed earlier, we can turn on and off the vegetation to see actual existing power lines and the future uh, placement of these. Now, some people will say, why is it all white? Well, because of all the snow covers, some of the details aren't necessary to have satellite imagery for such a representation. Now, if we keep moving forward, we have highlighted key locations where we want people to see and perceive. Sorry if we're stuck in a tree, and different areas. So here we have first time, an opening, and so on and so forth. And if we go all the way to the end, I hope you guys worked out because this is quite a workout today. We can still see them and we can highlight them even more to see the tops. So bringing it back over here. Because this is a presentation that's online, I turned off the sound, but we can hear the actual location, the actual dB levels through a configured process. We usually do this in a very controlled environment because we don't want people to personally turn up the sound until they actually hear it. You can imagine that if you're doing a wind turbine acoustic study, and that you're getting a readout of 29 dBs, which is under the usual threshold of what we hear on a day-to-day, and somebody's watching it from home, they're gonna say, I can't hear anything. So they're gonna turn it up until they actually hear it, which won't be representative of what they will be perceiving. So there are some limitations to some of the functionalities, but nevertheless, it is quite nice to have. We can also switch from day to night, which I will not show because time is limited. But if you want more details, you can definitely reach out to me and I'll be glad to show you. So back to the presentation. So a few seconds ago, we stopped at different areas within the scene, and on the left-hand side was the actual picture taken on site during the photo survey, and the right-hand side is what was produced inside the 3D environment. So quite representative of that space. We could have played a bit more with adding the same clouds, same level of details, but nevertheless, people recognize this spot and can identify with it. So we didn't just create one or two different functions within our environment to allow optimal stakeholder engagement. We actually developed a whole slew of them, more than 27. I won't list them all, but we have time of day where we can actually change on a slider the early early morning sun, midday, end of day, and night. We can add weather and fog, so rain, or if you have severe fog conditions for offshore plants or offshore wind turbines, that also will have a direct impact on visibility. Seasonal, as you saw, we have the dedicated winter level that we can create, but we can also have autumn leaves if we want to have those colors, but it doesn't add much except for aesthetics. The integration of acoustics. So we work in collaboration with our acoustics team here at WSP, who give us the ISO lines and dB levels that we're supposed to hear, and we're able to reproduce them accurately within the scene. We also have a virtual laser pointer that allows us to know exactly what distance are we from the turbine itself, as people have a hard time estimating the distances and feeling the perception through a computer screen. You can imagine that if you have a small tablet, which is a couple of centimeters wide, contrary to a 75-inch screen of your TV, or even if you have a VR headset, which all of these tools are compatible with, you won't get the same perception. So that's why we try to use these tools in the best manner, as we know that there are limitations to all of these mediums to which we display to. Wind directions, as I showed you, but we could connect it to live data, quick travel to key points of interest, keyboard navigation, and audio playback for narration in multiple languages if we wanted to have a virtual tour. All of these are quite important because we worked with different languages here in Canada, and we're able to use synthetic voices to generate the different translations required. So in summary, some of the takeaways that we have is by listening to our user feedback, we keep developing different functionalities that answer specific requests. And these are not only applicable for the wind farms, but also applicable to the other projects too that we work on, such as mining and others that I'll list a bit later. We have the acoustic simulation, which was a big add, but requires some calibration through hardware. Same thing for the nighttime. Even though I was tempted to show you the night representation, because you're seeing it on uncalibrated screens, the perception of the intensity can be quite different. So we have calibration tools for the nighttime representations. For us, we have the metrics to all of the number of users that actually go on site, but we don't necessarily measure the number of hits that we get. We're not a TikTok or YouTube. It's how constructive are the conversations through the use of the platform and through the use of these real-time tools. How does it stimulate the changes on site for different layouts to have an optimal win-win for the developer, but also for local residents. So not all stakeholder engagement sessions work optimally. I described a few items, but obviously if you have limited internet access, it can cause an issue, but we have solutions for that. We offer a standalone version that people can run off of their laptop. So we thought about all of the different environments. We actually went up north to the tip of Quebec, where internet is a bit is still accessible, but through different means. So we had a actual on-site presentation streaming the content from a dedicated laptop that was powerful enough. So to complete these things, we have what we call engineered visualization. And the reason I call it engineered visualization is because we use everything that is accurate. We don't make it look good to make it look good. It looks good because we found ways and we're using technologies that allows us to make it look good. But the power behind all of these solutions are the actual data that is driving in the background the precision. So we have an accurate representation margin of error between 3 to 5% of actual real life differences. So you can imagine that 3%, if your tower is 120 meters high, that's not even a 2-meter difference. So from 15 kilometers away or from 5 kilometers away, that 2-meter difference will not be perceivable that much. So it's the same level of accuracy that is used in military training, by the way. We have virtual rooms and portals where all of the data can be accessed through, and all of the visual impact studies, the environmental impact studies, these are a session in itself. We have the typical photo simulations, the interactive 3D model that I showed you a few minutes ago. And from there, we can create videos and animations for standalone. So where are we going next? we're deploying these for transportation projects and mining, which is transforming the landscape. It really helps people understand the size of the projects and the impacts. Being able to drive on a future road is quite impressive, and to stop anywhere and see what the point of views will be, quite nice to have. It also helps the design also at different stages. We're improving our data import for quicker turnarounds because we know that variants are important, and following customer feedback and stakeholder feedback, we want to make sure we're able to deploy those changes quickly. All of this is cloud hosted, so obviously it makes it easy for people to consult it when they want it due to our hectic schedules, and making a true digital twin once in operations where we can move forward and connect with actual sensor data. Because all of this is always at concept level, we have all of the base construction blocks to build upon those digital twin buzzwords that you've all heard of, and adding monitoring information, and also having dynamic GIS data tables and uh, construction dates and other maintenance related information to have a full digital twin. So the once in operation monitoring solutions, just a quick slide, but I won't go through all of it. I'll let you read it or pause on it during the recording of this, but it's pretty much how do we set up the sensors and how do we get the data? Same thing is applicable with our GIS portals, where all of the data is streaming and accessible through the platforms. So the positive outcomes, it may answer some of the questions that you're already thinking of. It's cloud hosted. We bill our customers every month. It's adds transparency to towards the public. They feel reassured and understand that this is a exchange. So we're quite happy with the turnouts. People can access it 24/7. We can reach people that usually can't get out, that may not be able to leave their homes or be present during the allocated traditional in-person assemblies. It also works on the connected phones, tablets, and computers, so there's no limitation to that. Heck, if you can get, if your fridge can play on the internet or log on to the internet and show, we could actually display it on the fridge. I think that's going to be coming in a few years, but currently not a high demand for that output. And when content is text-based, it can be read through the readers in the web browsers for people who have different needs and accessibility reach out. So we're quite excited about that. We support multi-languages, and we can even have the synthetic voices read it out. Price is based on modules, because I know I sometimes get that question. 3 to 6 weeks is our production time to get to it, and it's optimized for low bandwidth internet speeds, as not everybody has access to high speed. Some of our customers with whom we work with, and we are quite excited to add to this list every year. And this is just a sample of who we work with often. So I thank you all for listening and being present on this webinar. I could feel the energy in the room, and my email address if you have any questions. So we'll open up the floor. Let me try to see if I have to check the questions or if I'm going to get support. So,
Jen, I just
Catalina,
put Tom in the chat. So
excellent.
yeah, you want me to read it or you want it to go?
You can read them. I'll gladly answer them. I'll let you go through them. Based on the remaining time, I'll let you be the clock keeper.
Okay, perfect. So yeah, I think we have 10 minutes for Q&A. So we have question says, is the model suitable for assessing the visual impact of the SHEM inside of pre-agreed photomontage locations to determine the landscaping mitigation that may be required?
Uh, yes, well, it's a tool that completes the whole scheme of stakeholder engagement. So the base 3D model that is created either to create a photomontage or to create different outputs remains the same. It's how you export it and how you use it. So definitely it's a return on investment depending on how and where your customer is at along their design process. This type of solution may be a bit too uh, too evolved, but it doesn't mean that they won't reach it. So the photomontage is the first step. It's a quicker turnaround to do a photomontage, but afterwards to get into photo simulations, which are a bit more accurate with actual LiDAR based uh, positioning of geospecific locations that help align the images and the 3D. And then this completes it to give a wider range of locations where people wouldn't be able to go, such as in a ski trail or a pedestrian walkway that is 5 kilometers inside the land.
Okay, thank you. Next is how much survey is required in these remote locations to ensure that the existing trees are modeled correctly?
Yep, great question. The tree aspect is quite important to us. So there are two approaches. We know that every environment is a biome in itself, and each biome has a certain average height of trees. We may have random trees in there that go above those averages, but nevertheless, through different picture surveys on the accessible areas allows us to understand. Obviously, as all of you know quite well, Google Earth is an extraordinary tool now that helps us understand through Street View and other areas and other accessible pictures what we're going to see. So instead of having to deploy people on site, we can use those as a first set and then refine the actual heights through other picture and other data acquisition solutions that are required. So we build it in steps. Our customers ask us for an entry level approach, and then as these get refined over time, we also refine some of the data that accessible, especially for some of the points of interest. Now, again, because this is for stakeholder engagement, and these are quite vast, we don't want to put focus on certain points of interest more than others, not to attract any attention and say, why is that one more detailed? Is there something happening that required a more detailed approach for that specific location? So we try to be equal in all of the representation, not to um, favor certain locations more than others. And then we use governmental data to complete the information. Some governments have different quality of data sets. Here in Quebec, we have a specific column in our GIS data, if we get a bit technical, that gives us the median height and also the median mix of deciduous versus coniferous in certain regions. So through all of those, we're able to create a pretty accurate representation of the whole forest area.
Okay, thank you. Next one is how much did it cost to produce this platform, perhaps as a percentage of the overall project cost?
It's a great question, and unfortunately, because this is a overall external internal presentation, I can answer that question specifically through a direct conversation, but we can't directly disclose prices. I did cover about the duration that it takes to create, so you can kind of figure out certain things based off of that information, but specific um, answers, it depends on a lot of factors. The size of the area, if we have a 70 by 70 kilometer versus a 20 by 20 kilometer area. Some of our mining projects that you haven't seen, but I would have loved to show, includes the internals of some of the factories and some of the processing plants where you can actually go inside. So those would take more time to create and ingest and import those files. So it's a variety, but for a typical wind farm project, it's usually 3 to 6 weeks to acquire the data, make it work, and then convert it into our solution.
Okay. There's one interesting here. Working with vulnerable communities in Latin America, I find that although very visual, this model still feels quite distant from the reality of most of them, due to what we as anthropologists refer to as digital illiteracy. Is anyone on the team working with indigenous people or other traditional communities in similar conditions? I'd really like to hear about your experience.
Yep, and it's a great question. A few months back, we worked with Glencore to present a upcoming project up north in Quebec where we had different indigenous regions, and we knew we had to tackle it uh, in a certain way and use tools that allowed people to understand um, in a more visual manner what the project impact would be, because we all have our ways of communicating, and every group, every society has those different ways of setting up content. So we thought outside the box, and there's actually an article that's going to be coming out on our WSP website detailing that whole project journey, where we used anthropologists to support us and develop a certain aspect. So the 3D tools like this do not answer all of the questions and do not aren't a one-stop or a one shop fits all, or sorry for that misquote, but it's a one-stop shop. Here we go. We actually created 3D prints in resin that had specific heights and scales so that people could understand the ratios between the wind turbine and a pickup truck or another structure that they are familiar with, a house or another thing. And it became a very interactive session. So these types of tools, the real time is just one aspect of the solutions that we can use, but it's through the variety of tools presented to stakeholders that we're able to help them understand what the project will look like and how it will impact them, and allow them to ask questions and make their points of view based on that information.
Great. We have a couple more, so I think we can address them. So in the UK, we are required to verify visualizations, meaning ensure they're accurate. Is it possible to make this accurate?
So to answer that question, the level of accurate is can be quite large, and I understand your question as we have the similar aspect here in Canada and also in the US. In Canada, we have to confirm that it's geo-referenced and that it's using um, either LiDAR data or reference points in the image to confirm the location of each item. No, those are used in photo simulations, and that's the difference between the photomontage, which is more of a representation, versus the photo simulation, which is an accurate and geo-referenced render. Now, these 3D real-time interactive, they are based on geo-referenced data for all of them, but as mentioned, there are certain levels of inaccuracies due to available data. So for instance, if we're using a topography that is shared and it's at 1 meter resolution, well, we know right off the beginning that we will be 1 meter, possibly 1 meter off in the renders. And that is just because of the base information coming from the source files. So if you accumulate all of those possible variances, it can reduce the precision, but the house locations are accurate because we use the actual footprints on site. We have the satellite imagery that helps us confirm that we are correctly positioned. We have the 3D model that is accurately represented at the scale that was given to us by the customers. So by putting all of them together, as previously mentioned, it helps people to understand the impact, but it fits one of the solutions. It doesn't answer all of the uh, technical questions, as you mentioned. If it's how accurate is it and can it be used directly as a tool? So we would still recommend using the photo simulations to complete this type of solution.
Okay, the last one I just put in the chat for you if you can see it because it's on French and my pronunciation in French is really
Yes,
awful. Sorry about that.
I'll read it. No worries, I'll
Yeah.
read it for you.
Sorry.
Est-ce, est-ce que la modélisation présentée, incluant la modélisation sonore, est formatée pour présentation dans les casques de réalité virtuelle? So translation for everyone, can this work? Excuse me, can this work in VR? So yes, it can be formatted to work in VR because it's all 3D at the start. We can export to a VR experience and create specific points of interest. We always put them on the ground because nobody wants to have the sensation of dangling in the middle of space without any reference. So VR tools are mostly used on the ground to assure that it gives a better sense of immersion. Our projects are optimized to fit those to fit those needs, and the experience is quite impressive when you're inside the headset to see it from that perspective. So yes, definitely compatible with VR solutions. Très compatible avec les solutions VR, car on utilise la même maquette 3D et ensuite on exporte vers les solutions VR.
Thank you so much, Jen. Thank you so much all of you for joining. Thank you for your questions. We are just on top of the time. So I don't know if you want to say a few words to wrap up.
Thank you very much. It's been super fun to present what we've been developing here at WSP. We're still pushing forward, and every year we continue to create more content. So check back on us often, and don't hesitate to reach out on LinkedIn or the other platforms to connect.
Perfect. Thank you so much. Have a nice day, everyone.
Merci.